source here. If I considered a point source here, if I disturb this source, the light particles will move in all possible direction, right? Now, after moving this, all the particles will be at the same phase after certain instant of time. Now, you can join all these particles which are vibrating in the same phase. So these are the particles which are vibrating in the same phase. So these are the particles which are vibrating in the same phase. So this locus is what we called as a wavefront. So what is wavefront, students? It is the locus of all the particles in a medium. It is the locus of all the particles in a medium which are vibrating in the same phase. Which are vibrating in the same phase. So that is called what? Wavefront. So it is the locus of all the particles in a medium which are vibrating in the same phase. This is what we called as the spherical wavefront. What is this called? Spherical wavefront. And this is a point source. So the point source will produce us what type of wavefront? It produces a spherical wavefront. Fine. Now, suppose if you considered a linear source, linear source will be like this. There will be 2 point sources. They are going to be joined like this. For this linear source, the wavefront will looks like a cylinder. So what is the wavefront for the linear source? It is a cylindrical wavefront. So linear source will produce us what type of wavefront, Jerome? Cylindrical wavefront. So linear source produces what type of wavefront? Cylindrical wavefront. Now, suppose if you consider the point source at infinity. If you consider the point source at infinity. If you consider the point source at infinity, then the light particles comes parallel. Then this gives the wavefront, which is in the form of a plane. This is called as the wavefront. So this is called plane wavefront. Plane wavefront. So how many types of wavefront we have, students? We have 3 types of wavefront. One is called a spherical wavefront. Second one is called a cylindrical wavefront. The third one is called the plane wavefront. So in the case of a spherical wavefront, the point source should be placed. To get the cylindrical wavefront, what is the source we required? Linear source. To get a plane wavefront, what is the concept? The source should be placed at infinity. The point source should be placed at infinity. So these are the concepts of the types of wavefront. So using these types of wavefront, all this wave nature of light was explained by the scientist called by the name Eigen. So we considered the Eigen's principle of light. So what is the statement of the Eigen's principle? What is the statement of the Eigen's principle? Now, students, if I consider this is the source, this is the source. If I disturb this source, you will get a wavefront somewhere here. So this are the wavefront. Clear? So it will be continuous like a spherical wavefront. I'm not writing the complete sphere. Now this particle will also acts like a new source for the next disturbance. For the next disturbance. This is what we called as the secondary wavefront. What is SWF? It is a secondary wavefront. Using this, Huygens principle states the first one, every particle on the primary wavefront, this is primary wavefront, every particle on the primary wavefront acts as a new source for the next disturbance called secondary waves. And the secondary waves travels with the same speed as that of primary wave. What is that new wavefront called? It is called a secondary wavefront. What is that called? Secondary wavefront. So what is the concept of Huygens principle? First point, every particle on the primary wavefront, every particle on the primary wavefront acts as a new source for next disturbance. Next disturbance called secondary waves. Secondary waves. Second thing, this secondary wavelets, the particle which is forming the secondary waves, that particle we call secondary wavelets. Secondary wavelets travels with the same speed, as that of primary waves. As that of what? Primary waves. So you have to write these two principles, students. It has to write the Huygens principle. And whatever the new wavefront we obtained, that is called as what? The secondary wavefront. You can also write that. The new wavefront formed is called the secondary wavefront. So what is the Huygens principle? You have any doubt on this Huygens principle?
No, sir.
Okay. So according to the Huygens principle, you can tell every particle on the primary wavefront acts as what? Source for the next disturbance called secondary waves. And the secondary wavelets travels with same speed as that of the primary waves. Done. Now let me draw a wavefront. Let me draw a wavefront. For the first case, let me draw it for first one. You can draw it for which case? First we can take for prism, convex lens, and for concave mirror. Now for prism, you know this is the prism, right? Now on the prism, I will incident the two rays. Let us say the ray 1, ray 2. Now when the ray 1 is at this point, the ray 2 particle will be here. Correct, no? The ray 2 particle. Now, after undergoing the refraction, can you tell me which ray number will meet the prism first?
First one, sir.
Very good. First one. So it will undergo refraction first. The second one will incident later, but the second ray will come fast outside because the first ray has to travel a very larger distance inside the prism, which takes more time to come out. So when the second particle is somewhere here, the first particle is going to lag now. Now you join this. This is called a refracted wavefront. This is the refracted wavefront. So the refracted wavefront should bend towards the base of the prism. The refracted wavefront should bend towards the base of the prism. So this is how we are writing the wavefront for the prism. So how to write the wavefront for the prism means you have to write this diagram. The second thing, let me write the wavefront for a convex lens. Wavefront for the convex lens. Let me draw one convex lens. Now, here I will incident the three rays. Now, this is one, this is two, this is three. Can you tell me which ray will incident first?
Second one, sir.
Yeah. So it will travel, but it will travel larger distance. So it will come slow. But the first ray and the third ray will incident the lens later, but it will come fast. Reason? The thickness inside the lens at that position will be less. So these are the particles which are vibrating in the same phase later after refraction. So this concave spherical surface, this is called refracted wavefront. This is called the refracted wavefront. Now, similarly, you have to write the wavefront for concave mirror. Concave mirror. Let us say this is the concave mirror. This is the concave mirror. Here also we incident the three rays. Can you tell me which ray number is going to be incident first? Which ray will be incident first?
Second one, sir.
Hey, look at the diagram properly.
First and third.
Yeah, see, when the second particle is still here, when the first and the third ray is incident on the mirror. So the second ray will incident later. So this will undergo reflection first. So this ray will still go and it will come back. So the 1 and 3 will be leading. The second one is lagging. So this gives the new wavefront. This is called reflected wavefront because it is a mirror. No, it is undergoing reflection. So it is called reflected wavefront. This is called the reflected wavefront. So this is how you are going to write the wavefronts for these three different type students. That is for prism, convex lens, and for concave mirror. Now, what is the applications of this? Using the Huygens principle, you can prove the law of reflection. You can prove what? The law of reflection. You know the law of reflection is what? Angle of incidence is equal to angle of reflection. Yeah. Now let me consider a mirror. Let me consider a mirror. On the mirror, I will incident the two rays. Ray number 1, ray number 2. Can you tell me both the ray will incident the mirror first simultaneously? I mean, or you tell me which ray will meet the mirror first? The first ray is going to meet the mirror first, right? If you draw one perpendicular line, so this is A, this is B. So when the ray 1 is incident on the mirror at A, the ray 2 is at B, no? You can write this as perpendicular. No. No. ಗೊತ್ತಾಯ್ತು. ನಂಗೆ ಒಂದು ಲೊಕೇಶನ್ ಕಳಿಸ್ಕೊಡ್ತೀನಿ. So if I drop a perpendicular line here, this is called the normal. What is this angle called? Angle of incidence. Angle of incidence. So from A, the ray will reflect. The ray will reflect and it will come to the point C. When the ray reflects and comes to the point C, by the time the B will reaches the point D, right? So this particle is here. So when the first ray is get reflected to C, the second ray is moving from B to D. So this are the reflected wavefront. This is perpendicular. Correct, no? Any doubt in this diagram, students?
No, sir.
Okay. Now you show me the angle of reflection. This is angle of reflection, right? Black color to green color is reflection. Then from black color to red color is I. Because